So I have added a new section to the Moodle website, and it's this one here on automated testing. So testing is a topic that we're going to come back to a couple of times really in module. And next week's labs are dealing with this issue. So now usually my lectures contain demos and all that kind of stuff. Not much today, really. It's more talk today, unfortunately, but we'll try and get through it anyway. So automated testing, the focus on the automation. Testing is always important, but how do we actually automate that practice? Now, I'm saying as well here on this slide that your kind of mindset as a developer are these axioms or principles that I'm quoting there. One is that code that isn't tested doesn't work. That should be your kind of mindset as a developer. Don't assume it works, even though you've written the code, you looked at the code, what could go wrong? Something could always go wrong. And the second one then is interesting. It says code that isn't regression tested suffers from code rot, or it breaks. Regression testing is where you retest code that you were already tested previously in the development lifecycle. And the reasoning for that is, so if you're in the middle of your development lifecycle and you've already developed a number of features and you've tested them and they're working, and you now are embarking on developing some new feature or extending an existing feature, obviously you should test the new code that you've developed or modified, but you should also retest all of the stuff that you've already tested, even though you haven't touched the code of those other features. You should retest them. And that retesting is what we call regression testing. And the reason for that is quite obvious, I suppose. You may think that features that you haven't gone near recently still work, but they may not, because there may be a ripple effect from the code that you're currently developing. And it's this regression testing and the importance of it. So regression testing really means repeat tests that you've already done. Now, if you, and in software engineering, whenever we have to repeat tasks over and over again, then our immediate kind of thought should be, well, can we automate this process rather than having to do it manually? And so that's where automated testing really shines and has its value. If in an unreal world, you knew that a piece of code that you were developing was never going to be modified, then there probably wouldn't be much point in retesting, or sorry, in automating your tests. You just test it manually once and you never have to go near it again. If that was the case for an application that you were developing, then there probably would be an argument for not doing automated testing, but that's never the case. We're always extending an application, whether it be adding new features or fixing bugs. We're always going back to the code and doing some extra work on it. Now, just some 101 stuff in terms of testing in general. There are, historically anyway, there are kind of 4 levels of testing. Unit testing is where you're testing individual components, if you like, within your application. Now, what a component usually translates to these days is a class, or if the code that you're using doesn't have any classes, then it's going to be a function. So you would try and test each of those individually. Then we have integration testing. That's where you're focused on where your application is communicating with some external resources. Obvious examples would be a database, or if you're communicating with a remote web API, then you need to ensure that those hooks are actually working properly. Number 3 is system testing, where you're testing the entire application. Now, in system testing, you're obviously trying to ensure that the functionality of the system or application is as it should be. But I'm also saying that you may need to do performance testing, which is very different from functional testing, and you should keep them separate. Performance testing is where you're kind of stress testing the application against heavy workloads. That may or may not be an issue for the application. And if it is, then you need to automate the testing of that as well. We're not going to be looking at that area, though. We're going to be focusing on functional testing. Acceptance testing is essentially the same as system testing, but it's done by whoever the client or customer is. Now, that may never happen. Some customers may not require to do separate acceptance testing. They may be satisfied with the system testing done by the development team themselves, of course, giving them access to the system testing that is being done. But it's an option. For large organizations, acceptance testing, and for highly priced software, it may be an issue. So these are the terms we used historically, and we still use them today. If we're talking about web apps in particular, you know, and I did say at the beginning of this module that I'm kind of aligning this module with the web app dev, then in the web app world, in relation to testing, these are the kinds of terms that we use. Unit testing still applies. API testing, you know now from what little you've done on the web API module so far, that when you're developing a web app, you're developing the front end and you're developing the back end being a web API. And clearly we need to test that back end part of the system separately. End-to-end testing then is where you're testing. End-to-end testing is essentially the same as system testing, where now our end-to-end application consists of a front end running in the browser, a back end, which is a web API, and a database as well, potentially. So all three parts tested as one entity. Now, in the agile development environment, this is the kind of principles I'm saying that apply in relation to automated testing. Number one, we don't write our tests kind of using custom code. We should use a framework, a testing framework, and there are lots of them out there. And there are lots of them out there because automated testing is such an important part of the software development lifecycle. So don't write your own custom test code. Decide on a particular framework that suits your particular case, and then use that framework. And that's what we will be doing. An application's code must have a set of associated tests. So essentially, for each piece of code that you write, there should be a corresponding test that you have written as well. And so what this really means at the end of the day is that you've got two sets of code now that you as a developer will be making. You're going to be writing your application code, and you're also going to be writing test code. And as you see in this module, there's actually quite a lot of effort required to writing test code. And in some cases, the test code may be even more, maybe longer than in terms of lines of code, than your application code. So that begs the question, gosh, why put in all that effort? And the answer to that question is because of regression testing. You're actually going to be reusing that testing code over and over again. So it's worthwhile putting in the effort initially. 3, whenever a bug is found in your application, obviously you fix the bug, but you write a test then to prove that the bug has been fixed. And that test code now becomes part of your overall suite of testing software. Number 4 is a little bit tricky, really, but I'll explain it maybe later on. And it's this idea of writing your tests before you actually write the application code. That sounds like an odd thing to do, but there is sense behind it. So the term is we use test-driven development, as in we write our tests and they drive the development of the application the development of the application code. Consequences then of adopting all of these principles are fairly obvious. You've got better software, fewer bugs. You break this cycle between more pressure equals less testing. More pressure as in you're under pressure to deliver your application or some part of your application or an upgrade to an application to your customer. And the thing that tends to give way when you're under pressure to deliver is we do less testing. But that was in the days when testing was a manual task. But if you've got a whole suite of automated tests available to you, then retesting your application is just the simple press of a button, and it's all done automatically. You also end up with hopefully more maintainable code, I'm saying as well down here. So obvious benefits from pursuing this automated testing approach. Regression testing, I've already explained that, and that is where the value, I'm saying there, that's where the value comes in. Where do I mention it? That's where the value associated with writing all of this testing code comes from, because you're reusing it over and over again. Again, kind of high level stuff, but how do we design good tests? Because that is an issue. You could write lots and lots of tests, but they may actually be good tests. So what constitutes a good test or not? The first thing may seem maybe not so obvious, but well, it's obvious, right, that the starting point is you've got to have a clear and complete specification of the requirements required of the application code that you're developing. That has to be your starting point. And I suppose that's fairly obvious. Even whether you were doing testing or not, you've got to have a clear specification. The point though is here, right, that when we write our automated tests, we should write our automated tests, we must write our automated tests against the specification rather than against the implementation of that specification, the implementation being your application code. So if you're asked to write some tests, what you should not do, even though we probably all fall into that trap, is what you should not do is look at the code of the application that you've been asked to write tests about. You shouldn't do that. What you should do is look at the specification that was provided to the developer who implemented the application code. So your focus is on the specification and you write your tests against that specification rather than against the application code. Because the application code may not have implemented the specification properly. And if you're writing your tests against the application code, then you're only compounding the problem, because now the tests aren't really proving that the application does what the customer wants. All the tests are doing is proving that the code that has been written is working. But if the code doesn't match the specification, then it's no good. As we know, a specification expresses what the code should do, whereas the implementation expresses how it does it. So again, that's a mindset that you need to to have. And so obviously you can't do it unless you've got a clear specification to begin with. And if you're asked to write test for something and you don't have a clear specification, then you need to find out, how can I get a specification? What are we saying here? Oh yeah, just some terminology, like we write tests against what we call the target. The target is the target's behavior, sorry, we write tests against the target's behavior. The target now is the piece of application code, whether if you're doing unit testing, then that may be a class. If you're doing system testing, then it may be a particular feature of the application. That's what we call the target. And I'm saying that you write tests in terms of, you write tests in terms of the expectations of the target's behavior. What do we expect the target to do given certain inputs and certain kind of circumstances? I'll give you tangible examples of this in a while now, but So it's this idea of expectations. You know, if it's a method of a class, then it might be I expect the method to return a particular result when I provide certain parameters to it, and when the state of the target object is whatever it should be. And that's kind of what I'm expressing there. So there's this kind of terminology of the target. There's this idea of what your expectation, what do you expect the target to return, and what are the circumstances under which those expectations are expressed. The circumstances would be maybe the target's internal data have certain values, or if it's an application that the database has certain records in it. So our test target is a term that we talk about. So it's either, if you're talking about a unit test, as I said, it's either a function or a class. If it's a system, then it's a particular, it's the entire end-to-end application if it's system testing that you're doing. So if we think in terms of system testing, all right, we're testing an application, then what you should do in terms of writing good tests is to think in terms of what I'm calling user stories here. Now, user stories are those things that you try and get from your user requirements analysis. We know from probably something that you would have studied in first year or second year under software engineering, I think, as a module. User requirements analysis is where you talk to your customer or your client to try and extract from them what requirements they have of the application. That's what we call our user requirements. But whatever form that comes in, and it's usually some sort of document with lots of text in it, what you should try and do is extract user stories from that user requirement specification. And the suggestion is that you should structure these user stories following this given, when, then pattern. Given certain circumstances or a certain context, when some activity is carried out, like the circumstances might be the database has certain data in it. When a certain action is carried out, the user interacts in a certain way with the application, if it is a user-facing application. If it's a web API, then you make a particular HTTP request with certain parameters in the request. The then part is where you express what the response should be from the application in this particular scenario. Okay, so this given, when, then structure, I think, is a very useful way of expressing these user stories. Whether you actually write them down on pen and paper or not is not the point, but that's how you think in terms of user stories and how you decide what you will be doing. Then you see is you will be essentially writing a test for each user story that you come up with. And some examples, which are always a good idea. If we've got some sort of banking application, then an example of a user story might be this one here, which you can read yourself. Okay, here are some other ones in the same context, and they're all expressed in this given, when, then. So given that a bank account is in credit, when I withdraw, you can read it obviously, an amount greater than the credit card's limit, then, now I've put ... here, but the then really you probably would ensure from your customer or your client, what do you want the application to do under those circumstances? Now, hopefully that is clear from the user requirements specification, but if it's not, then you need to go back to your customer and get them to tell you exactly what they want the application to do in that particular situation. And that would be the expectation then for this particular user story. And here's another one here. Now, this given, when, then pattern, that really came from the area of user stories as associated with user requirements analysis. And when we talk about user requirements analysis, we're talking about the application as a whole. But you can still apply this given when then strategy when you're designing test cases for in unit testing, you know, whether you're testing a class or a function. And so, for example, here, let's suppose we've got this fictitious function, which is responsible, as its name kind of suggests, it's responsible for finding students from a particular country, where you pass into this fictitious function an array of students, and you pass in a country code or country name. And it's obvious what the function should be doing. And this might be a user story for that function. Okay, and this might be another user story. So we would write 2 tests as a minimum anyway, 2 separate tests for this particular function. And so what I'm kind of trying to get across here now is when you are, because the heading is how do we design good unit tests, or how do we design good tests, whether they be unit tests or system tests. The suggestion is try and follow or at least think in this given, when, then way, and try and come up with as many stories as possible and structure them along this given, when, then pattern. Now, I want to focus in now on unit testing. And as I said, later on in the module, we'll talk about end-to-end testing, although there's quite an overlap between the two in terms of the testing frameworks that we use and how we write testing code. And it's always better to have something tangible to discuss these things on. So you will get this an archive with next week's lab, and it's a very simple little 2-class project. So this is it here. Okay, and so I've got a simple product class. Okay, there's we don't really, obviously we don't do any testing of this because it doesn't have any non-trivial methods. It's just a simple class representing a product concept. Okay, so that's straightforward enough. And then I've got a catalog class, and the catalog is meant to be kind of a container for products. So in terms of its state, it has a title, but it has an array, potentially an array of products. Now, initially, what I say is, let's suppose we've just got 2 simple methods associated with this class, a find product by ID and an add product. That would be your initial starting point. But in the lab, then we'll add other methods as well. And as we add other methods, the objective will be to write unit tests for those other methods. And I intentionally give a short specification for each of the methods. Now, the methods are small, so it's a bit of overkill to be giving specifications. It's almost obvious from the method name what they do. But I want to try and reinforce that idea of you start with your specification and you then try and write tests based on that specification. Okay, so this is the only class as such. This is the only unit in my application so far anyway that I should write automated unit tests for. And it's trivial, I know, but so the find product by ID method, its specification might look like that. And in terms of coming up with test cases, I'm not sure if I mentioned that term test case. I should have, but a test case corresponds to one given, when, then statement or story, if you like, for a particular target. So in terms of test cases, then obviously, there are 2 test cases. You wouldn't need to come up with a given, when, then writing of them for this simple case study, but there you go. So there are two test cases. And if we write tests for those two test cases, then we can comfortably say that we have fully ensured that this method works properly. So we now have our specification for our target, which is our function. We have written two stories, and it's two are sufficient. We can determine from the specification two user stories or two stories are specific, or are sufficient, sorry. Now we've got to implement those stories. So how do we go about it? Well, we could actually just write them in a separate JavaScript file, okay, which I'm calling here your own custom automated unit test code. You could do it that way. But the problem is, once the application or once this particular class gets bigger and bigger, then you would find that that approach just doesn't scale sufficiently for you, and it almost becomes too much of a burden writing the automated tests. But for the sake of it, supposing we want to take that approach for the current state, if you like, of that catalog, if we go back to our catalog for a second, okay, that's its initial two methods. I've added in the add one as well, add product, and this might be, an attempt at writing a custom script, test script for the catalog. And so I'm just instantiating a few products here. It's all fairly simple stuff, some useful console log statements, and I've decided just to focus on testing the add product method. Okay, I probably should have written some tests for the find product by ID as well. But so here we go. I'm just calling the add product, and then I've got a statement that checks to see, let's see, what am I doing here now? Console log that, console log that. What if I run it first, maybe? Let's see. Which I happen to have done already. So I'll pull that up. Now we're gone from the live server now at this stage. So if we want to run our test script, we run it using the Node platform. And it looks like my tests are working successfully. Surprise, surprise. But, it's okay for a small class to write this amount of code. It's not that much of a burden. You can check it yourself. But as I said, this is just the amount of code I needed to write just for the add method. And one thing I had to be conscious of so this is essentially the first test case here. This is the first test case. And this is the second test case. And what I've got to be conscious of is when I'm writing the second test case, I've got to be aware of, well, what did I do in the first test case? As in, I've already put one product into the catalog, and then I need to be aware of that as I'm writing my second test case. And if I had subsequent test cases, not necessarily related to the add product method now, but to other methods, I'd have to keep track myself of what is the state of the catalog in terms of the number of products that have been put into it. That's what we call the circumstances or the context, the given part of the given when then. But I have to keep track of that myself. And that becomes complicated really as this script grows and grows. So overall, kind of this custom approach just doesn't work. And I think in the first lab, I actually get you to continue on writing this script, and you'll probably find it just gets a bit messy. So the solution to the fact that custom testing custom test scripts don't really work is to use what's called a testing framework. And there are lots of these unit testing frameworks out there. But what you would find actually, if you looked at a couple of them, is that they all follow generally the same idea. What they're all about is they help you to structure your testing code. And by putting good structure into your testing code, then it becomes more maintainable, because you do have to maintain your testing code as well as your application code. And I'm just saying here, like no matter what language you're working with, there are testing frameworks, unit testing frameworks available to you, which you may have come across. You may have come across JUnit before in the earlier years. There are ones for C#, there are ones for JavaScript. There are many unit testing frameworks for each of these languages and other languages. The one that we will be looking at is the Mocha framework, because I'm focusing on JavaScript in this module, as I said before, simply because you're doing a lot of JavaScript development in the web dev. So all of these unit testing frameworks, they all have these kind of features here. I think the very first one that came about was JUnit, and really the other unit testing frameworks copied the JUnit approach. I think that's historically, that's how it evolved. So I'm saying they facilitate good structuring of your test code. They provide a way of expressing test outcomes or expectations, because I said there earlier on that when you're thinking about testing a target, you're always thinking about expressing what you expect the target to do in a given circumstances and with certain inputs, if you like, because we're testing against the specification. We're writing our tests only with a specification in front of us rather than actual code. So if expectations, stating or expressing expectations is an important part of writing testing code, then hopefully the testing framework that we use provides a syntax to us that allows us to code those expectations. And you will see in a while what I mean by that. Also, you're going to have a lot of testing code, and in some cases, you will want to run all of your tests, but in other circumstances, you may only want to run certain tests. So the testing framework should allow you to state which tests do you want to run at any particular point in time. So we're focusing in on the Mocha framework. And okay, what does it do for us? I'm saying it provides an execution environment for automated JavaScript tests. So we write our tests, but the Mocha framework comes with more than just a library that allows us to write tests. It also provides an execution environment. And what you will see, what we'll find is that the testing code that we write, what we'll be using are 3 different constructs. So this is essentially how we structure our code. And initially, admittedly, it's a little bit off-putting, but after a little bit of usage, you get familiar with the structure. So there are what are called describe blocks, it blocks, and before and after hooks. And I'm saying down here, how do we use these constructs? So I'm saying that each a test case now is going to be linked to a story. Each test case is going to be wrapped inside an it block. The it blocks are wrapped inside a describe block, and you can have nesting of your describe blocks. So you can have describe blocks inside other describe blocks. And it's really a way of kind of grouping your test cases. So for each story, you implement the test associated with the story inside an it block, and then you group related it blocks. So maybe all of the it blocks or all of the stories linked to a particular method of a class, for example. You would group those inside a describe block. And you might have, presumably your class has lots of methods. So you'd have an outer describe block then for the entire class, and you would have inner describe blocks for each method. That is just one example, but there's lots of flexibility there. Describe blocks can be nested or grouped, which is really what I'm saying. If there's a piece of code that you want to run at the beginning of a describe block, then you put that piece of code into what's called a before block, a before hook, technically. Typically, what goes into a before hook section is, setting up, be it setting up a database or setting up the state of a particular target object, something like that. Now, so that's fine. In terms of expressing expectations, we use a separate library called the Chai library for coding our expectations. We could do it using the Mocha framework, but the Chai library is more powerful, really, and more expressive. And anywhere you read about Mocha, invariably it talks about using the Chai framework, Chai library, as well. So this is what I was trying to talk my way through there a minute ago. This is kind of how we structure our code now within a Mocha test file. So we have describe blocks, and we have before hooks, and we've got a describe block here, which is nested inside this one. And we've got it blocks, and we could have many it blocks, and then we close them all off. Now, syntactically, it is quite fussy, as we say, as in there's a lot of noisy syntax. As a by the way, we're passing a function here. Describe is essentially a function that's provided by the Mocha framework. That's another function provided by it. It is actually a function provided by the Mocha framework. So this is still, JavaScript code, even though we couldn't run it from the command line ourselves. We could only run this JavaScript code within the context of the Mocha runtime environment. That's what I said on the previous screen, that it provides an execution environment for us. But that execution environment that's provided by Mocha is really just sitting on top of Node. But the point I was making is that there's a lot of higher order function stuff going on here as well, by the way, but we shouldn't necessarily think of it in those terms, because we're essentially passing this function to this guy. These are strictly strings, but so it's a string, so you can put anything you want in there, but it would make sense, given that we're talking about unit tests now, that in the outer describe block, what you would put in this string here is the name of the unit or class that you're testing. Whereas, for example, maybe in this inner describe block, it might be the name of a particular method. So the suggestion now is maybe that I have a number of it blocks here inside this describe block, and each of these it blocks would be testing for a particular story associated with the particular method of the class. In terms of the given when then, the given stuff in your story, we tend to encode here in the before each, because in the before each, what you're typically doing is setting up, doing some setup code, whether that be creating an instance of the class and passing in the initial values of properties of that class. That typically is what goes on here. Or in the case of our catalog and our product, we might be instantiating some products here and also instantiating the catalog, and maybe even adding some products to the catalog. That all would be typically what might happen inside in the before each. It's kind of, as I said, it's set up code. The it block then is where, if you like, the when then stuff goes on. The when usually translates into you're actually invoking the method that you're testing. You're invoking it with certain parameters. The parameters will be dictated by your given when then that you've already thought about. And the then part is where you express your expectations. And we haven't seen yet, how do we actually express expectations in code? Because at the end of the day, this is all going to be JavaScript code. It's not some other kind of high-level language written on top of JavaScript. It's going to be pure JavaScript. So as I said, it looks kind of complicated, but after a while you'll get the hang of it. So going back to our terminology, we talk about our target. That's our, in terms of unit testing, that's our class or our function. We talk about unit test cases. Unit tests is comprised of test cases. Okay, yeah. So that if I go back to this, so all of this code would appear inside in a single file. There would tend to be a single test file per unit, and each test file we refer to as a unit test. Okay, so a unit test, and a unit test then is comprised of test cases. The test cases would be my it blocks. A collection of unit tests is called a test suite. So presumably you're going to have lots of classes in your application, and you're going to have a unit test for each class, and the collection of unit tests we refer to as a test suite. And I suppose if I just flip over to what it all will kind of look like at the end of the day. So here's, again, sticking with our product and catalog. This is what the unit test for the product catalog class might look like. So you know, there's a lot of code there. Now, this is the unit tests, not just for the two methods, the find product and the add product. I'm assuming that there are other, I've extended my catalog. Let me just look at the catalog. My catalog has, you know, lots of other methods as well. And you'll be adding these methods in the lab. So that's so my unit has, what is it, 78 lines of code. Corresponding test has right, 200 plus lines of code, but a lot of it is boilerplate, and you know, a lot of this stuff is, you know, all these describe and its initial statements are kind of boilerplate to a degree, but it's still going to be more lines of code than the actual target, and I mentioned that at the outset. So it's not an insignificant effort to write all of this testing code. And I've already said why it's beneficial. Let's just stick with it for a second. So here in the before block, what am I doing in the before block? I'm just creating an instance of my catalog, and I'm adding some products to the catalog. That's typically the kind of setup stuff that you would be doing. Here, this is focused on testing the find product by ID, and in the it block, look, I'm calling the method. So that's kind of the when, you know, when I call when I invoke the target, and that is my target, that method, with certain parameters. And this is where I'm now actually expressing what I expect the result to be. So this expect statement here is coming from, is provided by, it's a function, and it's provided by the child library. And it's kind of Englishy, like in terms of how you read it, and that's the whole point of it. It's easy to read. So even though we haven't seen anything about the child library, so result is what the find product by ID returns. Now I can tell you, right, that that method should return a pointer to a product object And I'm just saying here that I expect results, the results name property, that would be the product name, to equal the string. And that looks like it must be one of these products that I've put into the catalog up here. But anyway, that's just a kind of a preview of the kind of testing code that you would be writing using the Mocha framework. We're always interested in kind of principles or good practices, bad practices when we talk about any aspect of software engineering. In terms of testing, some principles I'm saying is that your test cases, that's really your it blocks, your test cases should be isolated from one another. There shouldn't be any overflow from one test case to the next test case or interdependence between them. It's because that just complicates things, because that then requires you, the tester, to keep that in mind. You know, if this test case executes after this test case, then is there a ripple effect between them? Hopefully the testing framework should make it easy for us to completely isolate each test case. And that's essentially what the before each hook is all about. The code inside the before each hook is actually executed before each it block is executed. So it essentially kind of resets everything back to the beginning again, before each test case, before each it block. So yeah, the before each, and there's also an after each, which I don't have an example there. They facilitate that. And the reason all of this is important is because even though, you know, when I showed you the test code there, it's not actually executed sequentially. You can't say that a particular it block is going to run before another it block in the sequence just because it appears in a certain order in the code. You cannot assume that. So that's why it's doubly important that the code inside the it blocks are completely independent of each other. Principle number 2, test the target's state. Okay, this is something that catches people quite a lot. So if we think about, we're just testing a method of a class now, clearly in your test case, you are going to be making statements about what you expect the result returned by the method should be. That's obvious. But if the method that you're testing makes some change to the internal state of the target object, then you should check in your test code as well that that state change did actually occur. Now, what do I mean by the internal state of the target object? If we think about the catalog, the internal state of the catalog is the array of products. So if I'm testing a method that is going to make some change to that array of products, then in my test code, I need to check to make sure it did actually change the state. That may not be obvious from the result returned by the method, because let's say the method might return a Boolean true or false. Yes, I carried out that task successfully. And you would check, you would state an expectation that it did return true or false. But in addition, you should also code expectations around the state of the target object. And you'll see examples of that in the lab. But it's one that people forget quite a lot. Some methods don't make any state change, and therefore you don't need to do any checking around the state. The silent principle, well, what that is just saying is don't have console logs scattered around your testing code. You may need to use them as you're debugging your testing code, because you're going to make errors in your testing code as well. But once your testing code is executing correctly, then you should remove any console logs from it. Hence, you make your test as silent in terms of its screen I/O. Number 4, have informative case documentation. By case documentation, I mean let's see. Essentially, you can see there that even though I didn't focus on it, the it block here, you're kind of expressing the when then. You're kind of expressing, sorry, the user story in English. Yeah. Where is it? Yeah. So try and make that as clear as possible, a clear and concise statement of what this particular test case is about. And you will get that from the kind of given when then statement that whether you've written it down on pen and paper or it's in your head. So that this is what I mean by the documentation associated with your test cases. And similarly for the describe block, it's easier usually for the describe block. In the describe block, the string is either the name of a class or the name of a method, but it doesn't have to be. But certainly the it blocks should be expressed clearly. They're the documentation part of the it block. Okay, that's principle number 4. How much testing? Let's see now. How much more do I have to go? Okay, child library. No, okay. I'm going to freeze it there actually, because even though this stuff is kind of all talk and no coding, it's still really important that you get these things right. So the testing principles, really important that you're clear on those, and they will become clearer when you practice it. And similarly for these issues around how do you know when you've done enough testing, because you keep testing and writing test cases forever, but adding more and more test cases doesn't necessarily mean that you're doing better and better testing. So there is a point at which you should be able to say, I've done sufficient testing now, and that's what this slide is helping you with. So I'm going to stop the lecture at this stage, and a bit like last week now, I may need to give a short lecture at the beginning of the lab sessions next week, but I'll come back to you on that later on. So, as I said at the outset, this lecture was a lot of talk, but sometimes we need to do that. Okay, so I'll leave it at that for now, and I'll talk to you next week. Thanks a lot.